How are you, my friends? This is review questions number 1 on pre-calculus topics related to lectures 1 to 16. Question number 1, given the two functions f of x e plus 10 to the power x minus 2, this is exponential function, and the function g 5 plus ln of x minus 10, which is logarithmic function base e. Let's find f inverse circle g inverse of 6 plus f inverse circle f of 10. Now easily we can see the second part is easy because this is cancellation property. So the second term here is 10. And here we have to find the inverse of each function. So we have f of x e plus 10 to the power x minus 2. There are 4 steps. As you know from lecture number 1, pre-calculus, you can put f of x as y, interchange x and y, solve for y, then you will get the inverse, f inverse of x 2 plus log base 10 of x minus e. Same thing we can do for function g of x, 5 plus ln of x minus 10. Use the 4 steps from lecture number 1. G inverse will be 10 plus e to the power x minus 5. So what do we do? As I mentioned, the second term here is 10. 6, I replace it in the inverse of g. So 6 minus 5 will be 1. So 10 plus e. 10 plus e is the image of 6 by using the function the inverse of g. Now I put 10 plus e in the inverse of f here. So in the x, I put 10 plus e, and there is a minus e there. So it will be log of 10. Log of 10 is 1, plus 2 is 3, plus this 10 here will be 13 is the answer. Question number 2, graph the logarithmic function f of x equals log base 6 of the absolute value of x minus 7, and then minus 1 outside. This is like part A. And then we need to write where the graph of the given function is below the x-axis. Now here we see that the absolute value on the x. So I can graph the function without shifting. Remember, I need the graph without shifting here. So it will be log base 6 of absolute value of x only. This will be the graph here, 2 pieces there. So this is the graph of f of x log base 6 of absolute value of x without shifting. Remember, there is a shifting here on the right, 7 units, and 1 unit down after we do this graph. Now to do this graph, we have to take 2 cases. X positive, that means the absolute value of the x is x. So the function becomes log base 6 of x, which is this part here on the positive x. If x is negative, absolute value of x will be minus x. So this becomes log base 6 of minus x. That's a reflection about the y-axis. So these 2 pieces together will give the function log base 6 of the absolute value of x. Now we can shift on the right 7 units. You see here the vertical asymptotes at 7, and then shifting 1 unit down. So for sure, we have to find the x-intercept. Let y is equal to 0. So I put all this log is equal to 0. Take 1 on the other side. Use the LE rule here. Change this logarithmic into exponential. So it will be x minus 7 inside the absolute value will be the base 6 to the power 1. So now we can have case number 1 in solving absolute value equations. So x minus 7 is equal minus 6, or x minus 7 is equal to 6. So x will be 1 or 13. You see, these are red dots here. These are the x-intercept of the whole function with shifting. Now, where is the graph below the x? Below the x, from 1 to 7, open, union 7 to 13. Now, question number 3 says, if the ray OP rotates 2 pi over 9 radians per minute about O, find the angle in degrees generated by OP in 300 seconds. B part, find the diameter of the circle if the distance traveled is 20 pi centimeters. Now let's look at the given here. W is the angular velocity, 2 pi over 9 radians per minute. Time is t, 300 seconds. S is 20 pi centimeters. In the first part, we have to find the degree measure of the angle. Let theta be the angle. So we know the formula W is equal theta over time. Cross multiply here. We get theta equals W times time, 2 pi over 9. This is radians per minute. So we change here, we convert 300 seconds into minutes. So we divide by 60. So when you multiply 10 pi over 9 radians, this is the angle. Now we have to convert that to degrees. So we multiply that by 180 over pi. It will be 200 degrees. In the second part, we have to find the diameter. So first we find the radius, then we multiply the radius by 2. We can use the formula S equals R theta. So R will be S over theta. 20 pi divided by 10 pi over 9. Remember here in this theta, we have to find theta in radians. So you can use only the radian part for theta, not 200. So 20 pi over 1 times 9 over 10 pi. This is the reciprocal. It will be 18 centimeters. This is radius. So the diameter will be 2r, 36 centimeters. Now, question number 4 says, if alpha is an acute angle satisfying 4 sine of alpha is equal 5 cosine of alpha, let's find secant of minus alpha plus cosecant of minus alpha. Let's rearrange the equation. 4 sine of alpha is equal 5 cosine of alpha. We can divide both sides by cosine of alpha. We get tan of alpha is equal 5 over 4. Now, by definition of tangent function, it will be y over x. So y will be 5, x will be 4. So we can use Pythagorean theorem. X squared plus y squared is equal to r squared. So r will be the square root of 41. R is always positive. Now, the secant function is even function, but the cosecant function is an odd function. So we can have here secant of minus alpha is the same as secant of alpha. Cosecant of minus alpha will be minus cosecant of the alpha. Now, secant of alpha will be r over x, the reciprocal of the cosine, and cosecant of alpha will be r over y, reciprocal of sine of alpha. And there is a minus in the middle here. So the LCD will be 20. So it will be square root of 41 divided by 20. Question number 5, from the top of a building, a man is looking at a house in the area with an angle of depression of 30 degrees. If the height of the building is 61 square root of 3 meters, how far is the house from the base of the building? So we can make here a sketch. This is a building here. Let h be the height of the building, and let x be the distance from the house to the building. So the angle of depression, this one here is 30. So we can conclude that this one is 30. So we can use this triangle or this triangle. Don't be confused. Don't try 30 here. You see down here, 30 is wrong. 30 should be between line of sight and the horizontal. So tan of 30, we can say h, the height of the building, divided by the x. Now x will be, h is 61 square root of 3 given. Tan of 30, which will be 1 over square root of 3. So it will be 61 square root of 3 times the reciprocal here, square root of 3. So the answer will be 183 meters. Question number 6, find the exact value of sine minus 930 degrees times cotan of 26 pi over 3. So we can find each value separate, then we multiply. Now we see there is a minus here in the angle. So we know the sine function is an odd function. So sine of minus t will be minus sine of t. So we can use now 930 degrees, and we find the coterminal, because 930 is greater than 360. So 930 minus 2 times 360 will be 210. 210 is an angle in quadrant 3. So we can find the reference angle. 210 minus 180 will be 30 degrees. So let's go back to the function now. Sine of minus 930 will be minus sine of 930, because I mentioned here it's an odd function. Sine 930 will be the same as sine 210, because this is coterminal. See 210 here, and the minus will stay. Now we leave this minus inside. Sine 210 will be in quadrant 3, so it's a minus. So we put another minus from quadrant 3, and sine of the reference angle, sine of 30. So minus and minus becomes plus. Sine of 30 will be half. Now the other angle, 26 pi over 3 is greater than 2 pi. So we can subtract multiple of 2 pi. So we subtract 8 pi here. From where we get 8 pi, we divide 26 by 3 mentally, and very quickly it will be 8 point something. So I can subtract 8 pi. So it will be 2 pi over 3. 2 pi over 3 is an angle in quadrant 2. Pi over 3 is 60. 2 times 60, this is 120. So we can find the reference angle, pi minus the angle itself. It will be pi over 3. So cotan of 26 pi over 3 will be minus, y minus in quadrant 2, cotan of the reference. So it will be minus 1 over square root of 3, which is minus square root of 3 over 3. So we can write the final answer now. This will be half, and this will be minus square root of 3 over 3. When you multiply, you get minus square root of 3 divided by 6. Question number 7. If the sum of all solutions of this equation, 32 to the power x plus 2 to the power 2 plus 5x is equal 15. Now remember here, the sum of the solution is written as log base a of nth root of b, where a, b, and n are prime numbers. So let's find a times b times n. Now the given equation is an exponential equation, and the sum of the solutions will look like this. So we start by playing with the powers here. A to the power m times a to the power n is equal to a to the power m plus n. We know that from the algebra course. Multiplying exponents with the same base, but we have to use it backward. So 32 is 2 to the power 5, 2 to the power 5x, the first term here, 2 to the power 2 times 2 to the power 5x. Now this is a here is 2, is equal to 15. Now let n, we can change the variable here to make the question simple. Let n be 2 to the power 5x. So it will be n, the first one is n, 2 squared is 4, 4n is equal to 15. So we can add here easily, 5n is equal to 15, we divide by 5, we get n equals to 3. Now we can go back and write n here, 2 to the power 5x is equal to 3. Let's use LE rule. LE rule, we have exponential here. We can change it to logarithm. So 5x will be log base 2 of 3. We divide by 5. So x will be 1 over 5 log base 2 of 3. I can take this 1 over 5 and the power of 3. 3 to the power 1 over 5 will be 5th root of 3. So this is the only solution, and this is exactly the sum of the solutions. So log base a, so a now is 2, and this index here 5. See the index n here, so n will be 5, and the radicand, the number under the radical b is 3. So we multiply a times b times n, so it will be 30. Question number 8, find the number of all x-intercepts of this function minus 3 sine 1 over 5 times 2x minus 3 pi over the interval, closed interval, minus 17 pi over 2 to 7 pi open. Now for the solution of question number 8, we take the function and we have to multiply 1 over 5 times this bracket here. so that we can find the argument. So it will be 2 over 5x, or we can write it as 2x over 5 minus 3 pi over 5. This is the argument. Now, to find the x-intercept of this function, sine function, we put the argument equals n pi, where n is integer. So 2x over 5 minus 3 pi over 5 is equal n pi. Take 3 pi over 5 on the other side and multiply by 5 over 2. You will get x equals 3 pi over 2 plus 5 pi n over 2. This is the equation for x-intercept. So let's create an inequality here using the given interval. The given interval here is minus 17 pi over 2 closed. You see that one? And 7 pi open. So I put 7 pi open, just less than that, and minus 17 pi over 2 I put here closed. And inside here I put the equation for x-intercept. Now I subtract 3 pi over 2 from each side. You see here, minus 3 pi over 2, minus 3 pi over 2. I will have in the middle here 5 pi n over 2. Then I multiply by 2 over 5 pi to get n. So please do it here slowly. You will find n greater than or equal minus 4 less than 11 over 5. 11 over 5 is 2 point something. So this is less than 3. And we need the integers. N is integer. So I can take n is equal to minus 4, minus 3, minus 2, minus 1, 0, 1, and 2. So there are 7 x-intercepts in the given interval. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.